So in this session, we discussed some SIC bar XC simple program. So previously we have seen the SIC program and the same programs I have taken and how it is written in an SIC bar XC. That one we will see here. First one, simple data character movement. First read the data and character movement. That one we will see. So here also program writing in the same way. This section will be for label for this line what it is, and for looping purpose or on the name of the program we written in the first one, and the second column is for a instruction, and this one is the data or the address. Like that the program will be divided into the three sets. So here first one, load 5 to the accumulator A. So A will directly contain the 5, and that one 5 it will be given to the another register. That one we call it as the alpha. So alpha it will be from the accumulator, it is shifted to 5. Store alpha. So store what is there in the accumulator, that will be stored into the alpha. Okay, and LDA hash 90. This one is hash 90. We will see here. See, alpha is a reserved word. It will reads only the numbers. But whereas the reserved bytes, it will reads the characters. So here hash 90 means it will convert to the respective ASCII, that will becomes the Z. So previously accumulator is empty while 5 is shifted to the alpha, and here the Z will be stored here. 90's ASCII is Z, and that will be stored character where we are storing to the another register C1. See, C1 it reserves the byte which is of character. So Z will be moved here, and again accumulator will become empty. Okay. So previously SIC machine instead of 590 we have written in the character FIVE and Z we have written here. So here directly we give the numbers. That is a simple data character movement in an SIC bar XC machine. And here next second example I have taken it as an arithmetic operation. Same example which I have discussed in an SIC machine, the same example here. So load to the INCR. For INCR, whatever the value is there in an INCR, that will be loaded. Continuing, arithmetic operation, load, yes. So here load value of INCR into the register yes. We have seen there is a register yes. Whatever the value is there in the INCR, that will be loaded to the register. So load the value of INCR into register yes. Then load the alpha into register A. So what is there in the alpha, that will be stored into the register A. We are doing with the value. So now add S and A. The register operation is possible in SIC bar XC. Whatever the value it may be there. So it may be 2, it may be 3. These will be were added. Add S and A. The values which is there in a S and A, it will be added. So then subtract minus 1. See here where it has to subtract, by default it will be subtracted the value which is stored in accumulator, that one it will be subtracted. So minus 1 it will be done, and it will be stored in the beta. The same value what we have done in our previous program, here also we are doing INCR plus alpha and minus 1, that will be stored to the another kind of register, that is a beta. So beta will be the value of what is there in an INCR plus what is there in the alpha and the minus 1. So this is the alpha, what it is? It is a reserved word. Beta, reserved word. INCM, it's a reserved word. These are all the numbers and these are all the size. 1 byte of a numbers it will be. See, like this. It is a label. At the somewhere at the end of the program, this will explanation of that variables they will be given. Okay. So third one we have taken it as a sample, subroutine, call and record input operation. So subroutine, I mentioned that subroutine it is nothing but a function kind of a thing. So we have to call to the function and we have to get some value from the function. That is a subroutine. Here, what is this program is doing now? It will read the 100 bytes, 100 byte of value it will read. So how it is program is written? Let's see. J sub is nothing but a jump to the subroutine. Which subroutine? I am giving the name it as the read. And where is the read? It may be somewhere in the program. If a hash indicates that, so it may be in the somewhere in the program. So we have to jump to the subroutine read. So this will become the name of a subroutine. Read will become the name of a subroutine. So read what it is doing. Initialize index register to 0. So X indicates it is an index register. So index register we will initially make it as a 0. Okay. And LDT, T is also one of the register we have seen in here. So that LDT we will T register we will initialize it to the 100 LDX and then LDT. Okay, so then within the same function only there is a R loop. For this statement we are writing a looping statement R loop. So R loop what it will do we will see. TD we have seen it is for the test device. It will test device whether the input device is ready or not. Okay, if it is not ready, we have to keep on checking. That is done by the JUQ. JUQ check condition and jump. Okay, if device is not ready, it will be keep on continuing. When the device is become ready, then it will come to the RD. RD is nothing but a read device. Whatever is there in the INDV device, that will be we have read. And STCH store the data byte into the record. There is a, what is a record? Record is a reserved byte record which is of maximum size. It will be stored here. So here record store data byte into the record. Whatever all this X is there, that will be, see, X, whatever X is there, that will be stored to the into the record. So 0, it will initially it will be read, and TIXR means increment and compare and check. So only TIX means it will increment and check. For loop we use a I plus plus kind of a statement in C. So here increment and check. So increment the increment where in the T. T where we have to check, in the T we have to check. So X will becomes now 1. Whether it is equal to 100, no. So if it is not true, we have to jump to the arrow. We have to read the 100 characters. Okay. So like that, again 1 it will becomes, again 1 character will be read. Again when TIXR it will come, it will increment to 2, whether it is less than, whether it is equal to 100, no, 2 will be read. So when TIXR, when 100 it becomes 100. So when it becomes 101, it becomes the false. Then this it will return to the subroutine. So when all the 100 characters are read, R sub is nothing but the return to the subroutine, where here it will go back to the condition from where it has got. So it will execute the next statement, return to the subroutine. So here INDEV, what is the input device? It is a byte, and XF1, I told you X and F1 is a name we have given for a input device. Name we have given it for a input device. And record, what it is a record? It is with a reserved byte, which is having the value 100 byte. 100 byte it is the storage maximum. So understand here JEQ indicates check the condition and jump, check the condition and jump, DIX increment and compare. Where we are comparing, T we are comparing, and jump to the loop. So this loop will be continued here. So this example combines the both subroutine and input and output statement in an SIC bar XE machine. Same program, please compare the program with the SIC program and how it is written in the SIC bar XE program. Compare and check with it.